as an operationalization, I would suggest we start small because there are many unknowns. Start with an initial conservative loading limit, and the STP should be reasonably large. Don't go for small ones because we cannot justify a proper reception facility and sufficient skilled people to run these. So if you have a reasonably big STP, then this becomes easier to do. Sufficient spare capacity for the near future. And the end products, I've mentioned this, the logistics and the remote decanting stations, institutional issues, co-management and the regulation. The variability. So this variability of sludge is something we must watch out because it can vary from tanker to tanker. And it could cause some shock loadings because the microorganisms are not acclimatized to that kind of waste. So it gets, the shocks can take some time to recover. And you could do some simple tests like pH, conductivity, odor, observation of color and odor and so on. And also have some kind of control on the desludging operators to ensure where are they bringing this from and have some accountability on them. So these are the things that could go wrong: too much flow, too much solids overloading the grade primary solid system and so on, too much organics, which will then impact retention time, reaction time, and insufficient oxygen being transferred, shock loads, variability, which, as I mentioned, the microbial populations are unable to acclimatize. Toxins, if there's no control on the tankers, then they could be bringing in some trade or industrial waste, which could be toxic, and that could kill off the microbial populations in your STP and cause upsets. And when we are discharging in decanting stations, blockage, grid settlement, pump clogging and abrasion, and blockages of pumping mains. These are possible things that could happen if we do not have a proper pre-treatment before they are being discharged. So for new treatment facilities, I think it's much easier. We can actually design to co-treat and any possible potential problems, we could design them out. And for existing facilities, we need to modify, retrofit or adjust, retreat, blend or equalize, reduce the volume added, monitor the quality and the source and regulate tank operators, increase solid handling capacity. Even if you had a solid liquid separation, that would result in solids which have to be handled, right? And increase oxygen supply and increase tankage capacity. So these are some of the adaptations that you may be able to do to make your STP able to handle it. Some examples of what we have in Malaysia, we have hundreds of facilities which are doing co-treatment. And this is one, which is a very big STP in Kuala Lumpur. It serves about 1.8 million population, but it is also co-treating sludge coming in tankers. So the tanker discharges and there is some screening, grit removal and solid liquid separation using centrifuge. And then this sewage is then sent through the STP for co-treatment. The STP has been designed to co-treat. So this is one example of that. And here in Malaysia, like I said, the reuse is not so prevalent and all these are dumped in landfills, you can see here. So the hopper is discharging directly to this truck, which will then take it to the landfill. And here we have one where the existing STP was underutilized and a retrofit of a mechanical dewatering unit, which is again a centrifuge, was installed together with some preliminary screening and grit removal. And tankers discharge here. And after solid liquid separation, it goes through the existing STP, which then now is being better utilized because of this sludge. This is from Manila in Quezon City. Again, this has been designed to co-treat. So they have septage acceptance and then with the dewatering press, this is a screw press. And then it's co-treated together with sewage that is coming from this facility. It's not a very big facility, but this has again been designed to co-treat.